Pre-calculus students, welcome to today's 6162 application notes. Today we're going to be looking at how law of sines and law of cosines can apply to real-life problems. I hope you'll learn a little something. I'll do my best to inform you well of what we're talking about, and hopefully we can get this figured out together. So let's start with number one. It says, because of prevailing winds blowing from the west, a tree grew so that it was leaning 6 degrees from the vertical. At a point 30 meters west of the tree, the angle of elevation to the top is 22.5 degrees. Find the height of the tree. All right, so I'm going to start with this. I'm going to do a little sketch. Let's say that represents the ground. This represents the tree. Now remember, it's not a vertical tree. The wind is blowing so that it blows, or excuse me, so that it leans that direction. And then we know we have this right here to use to find our angle of elevation. And let's label everything we know. All right, so we know that the tree was leaning 6 degrees from vertical, so that means this angle is not 90 degrees, it's 96 degrees. The angle of elevation is right down here, that's 22.5 degrees. And this point right here is 30 meters west of the tree, it says, so that's 30 meters. And essentially we have everything here that we need to be able to find the height, which we're going to call h. And I know there's like the argument of, okay, so is the height of a tree vertical? We're going to measure it the same way we measure your height. If you're sitting down, laying down, or standing up straight, you are still the same height, and so we'll pretend that trees go by that same system, so it's length from base to the top of the tree. All right. Now, one thing that I'm noticing when I solve this triangle, first of all, it's angle, angle, side, so I know I'm going to use law of sines. I need to find this angle right here so that I have a side and an angle paired, and you can just simply subtract, and you'll get that that angle is 61.5 degrees. All right, the 96 leaves 84 for those two to share, so that makes sense. And we can set up our law of sines. So the sine of 61.5 degrees is to 30, as the sine of 22.5 degrees is to h. And I think you guys are pretty comfortable with the calculator work right now, but we should get 13.06 meters, and that would be the height of the tree. Guys, if you can't get 13.06, if you're getting something different, talk to the person next to you and take a look at your calculator and see if you can help each other out on that. And on to number two. So in this one we have a boat race. It starts at point A, proceeds in the direction of south 52 degrees west to point B. And what I'm going to do is start by trying to sketch this thing a little bit. So I'm not going to worry about being precise, but I'm going to get a decent sketch. So we're saying south 52 degrees west to point B. We don't know distances. We'll find that later. And then we go south and 40 degrees east. So there would be south 40 degrees east is going to take us somewhere like that to point C. But then here's the key thing. Point C is exactly 8 kilometers south of A. So I need to draw that vertical line, and then I can fortunately just adjust a little bit so that things match up. That'll work, and that'll work. All right, so our triangle should look something like that. That's the pathway for the boat race. All right, so let's mark down what we know. First of all, some labels. We know that's point A, that's B, that's C. We know the direction here was south and then 52 degrees west, so I know this angle right here has to be 52 degrees. And it might be easier at point B to get the bearing there if I actually sketch a little vertical line here to kind of envision what we're talking about. So here in this one we're talking about going south and 40 degrees east. So that means right here we have a 40-degree angle. Okay, now obviously that's not inside the triangle, but we have alternate interior angles, so I can call this angle 40 degrees because these vertical lines are both parallel, and we have alternate interiors, and we got it. Okay, the other thing we know is that point C is 8 kilometers directly south, so this is 8 kilometers right there. Now if you note, we have angle side angle information, and honestly anytime we have two angles of a triangle we have a third, and we can figure that out. 40 plus 52 is 92. That leaves me 88 degrees for angle B. Now what I'm going to do is set up law of sines. We have an angle and an opposite side paired. So sine of 88 degrees is to 8. And then you can choose which angle you want to find, or which side length you want to find, I should say, as the sine of 40 degrees is to C. And I'll go ahead and set up the other as well. And this will be the sine of 52 degrees over side length A. Now I didn't label these, but this is side C and this is side A right here. And I guess it's probably important to make sure you know what's the point of this problem. What are we trying to figure out? Well, you can see it says find the total distance of the race course. Now I know C is about 5.15 kilometers. You can just punch those numbers in your calculator to come up with that. And I know that side A is about 6.31 kilometers. And if I take the pathway to be A to B to C and then back to A, I can find the total distance by just doing the side lengths of A, B, and C added together, and I get about 19.46 kilometers. That is the length of the course that they're racing. All right, on number 3, what we're looking at here is a problem where perhaps a little sports knowledge comes in handy. But we're talking about the diamond of a softball field, and I'm going to go ahead and sketch the diamond. Now notice when I say it's a diamond, notice I'm drawing a square, but realistically that is the shape. It's just rotated like that. All right, and let's talk about what we know. It says that the pitcher's mound is 43 feet from home plate, and note that it's not exactly halfway between home and second. It's on the segment that connects home to second, so let me go ahead and sketch that little segment there. So it's along this segment you see here, but it's not right in the middle. That's the key. Our sketch, it's going to probably look like it's the middle, but I'm just going to put it right there. And it says we want to know how far the pitcher's mound is from first base. And so that would be this distance from here over to here, and I'll label that as D because that is in fact the distance we're looking for. Now let's talk about what we know. Maybe a little bit of knowledge about the baseball diamond would come in handy, but these are all right angles as you work your way around, and that includes home plate here. And so basically what we have right here is a 45-degree angle. Now it might be tempting to mark this as a 90-degree angle, but remember the pitcher's mound is not exactly in the middle, so you can't do that. But what we do know is that this distance is 43 feet. We know the bases are 60 feet apart, so that's 60 feet. And look what we have here, folks. We have side angle side information. That's law of cosines. So D squared is equal to 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of that included angle, 45 degrees. Again, just a little work with our calculators to clean this up and get a nice decimal approximation, and I'm getting about 42.43 feet. So again, the pitcher's mound is about half a foot closer to first base than it is to home plate. All right, for our last problem today, we're looking at another navigation situation. I've already sketched some of that for you on your notes and on mine here as well. So a ship is traveling 60 miles due east and adjusts its course northward. I don't know why I didn't write the 80 on there, but here we'll add that in. I can handle that, I suppose. There's 80 miles, all right? And after traveling 80 miles, the ship is 139 miles from its point of departure. Describe the bearing from point B to point C. Now when you think about bearing, we're going to have to think about this just a little bit because it's not just the angle here. There's a little more to it because remember bearings are always compared to due north or due south when we're talking about boats. So if I were to have like a vertical axis right here, what we'd really be looking for is not the whole angle, but this portion of it right here. We can call that theta. And again, we have a right angle right here since that's vertical. But knowing that we're trying to find angle theta, really if I just find the big angle, then I could subtract 90. And you know, we have this nice little tool called law of cosines. You might have heard of it before. That helps us to find things like missing angles and triangles where we have side, side, side information. So that's what we're going to do. When 139 squared is equal to 60 squared plus 80 squared minus 2 times 60 times 80 times the cosine, and I ran out of space, sorry. We'll try writing that again. All right, minus 2 times 60 times 80 times the cosine. And I don't have a name for that angle. I'm just going to call it angle B for now. And then we'll figure out how to adjust it after we're done. Now, just by simply subtracting 60 squared, subtracting 80 squared, dividing by negative 2 times 60 times 80, and then doing the inverse cosine, that gave me my angle B. And this is where we love law of cosines, right? Because if we had to use law of sines, we never would have come up with 166.15 degrees. We would have had some acute angle and some ambiguous case that we wouldn't have enjoyed so much. But here's the deal. Law of cosines, that's your friend, and it worked out for us nicely. So here we go. We know that theta is essentially angle B minus 90 degrees because that's the rest of this angle here. So I know theta is 76.15 degrees. Now we're almost there. Remember, the boat is going from B to C. That's the portion where we're trying to find the bearing. So it would be north, theta degrees, east, or in this case north, 76.15 degrees east. All right, folks, I hope this works for you today. If you have questions when I'm back, we'll be free to discuss and try to clean any things up that you're unsure of. And you guys make sure you work hard on the assignment and have a spectacular day.